Hello everyone, welcome to Dakshana e-classroom program. I hope everyone did their best in exam DT06 for NEET 12th class, and let's talk about its solution. So I will be talking about the part solution for part physics. So let's start with question number 1. Two light waves are represented by y1 4 sine omega t and y2 3 sine omega t plus pi by 2. The resultant amplitude due to interference will be, so here y1 is given as 4 sine omega t, sine of omega t, and y2 is given as 3 sine of omega t plus pi by 2. So these are basically two waves and their amplitudes 4 and 3, and they are superimposing. Then we know the resultant amplitude is given by under root a1 square plus a2 square plus 2a1 a2 into cos of phi, where phi is the phase difference and phase difference between these two is coming out to be pi by 2. So substituting the value, it comes simply 4 square plus 3 square plus 2 multiplied by 4 into 3 into cos pi by 2, and solving it we are getting a is equal to 5 whatever the unit it is, centimeters. So answer is 1. Question number 2. Amplitude of two interfering wave is a and 2a respectively. So amplitude of one wave is a, another wave is 2a. The resultant amplitude in constructive interference, it's talking about resultant amplitude in constructive interference. So constructive interference means phi is coming out to be 0. In that case, a resultant is equal to a1 plus a2, and that is equal to 3a. This is your answer, which is matching with third. Question number 3. Intensity of interfering wave in an interference pattern is I0. The resultant intensity at the point of observation. This is a simple straightforward formula based. Actually, we know I is equal to under root, it's I1 plus I2 plus 2 I1 under root I2 into cos of phi. Under root this, and simplifying it we can write, because here I1 is given as I2 equal to I0, and simplifying it we get actually it's 2 I0 1 plus cos of phi. It can be further expressed as 4 I0 cos square phi by 2, but no expression is given for this, it's only this one, so which matches with option 1. Question number 4. Two sources of intensity 2i and 8i are used. So I1 is 2i and I2 is 8i, and used as in an interference experiment. The intensity at a point where the wave from two sources superimposed with phase difference. So here three cases are given. Phase difference A, phi is equal to 0, phi is equal to pi by 2, and C, phi equal to pi. Right, so we know actually we can use this relation I1 and I2 here. Then substituting it actually in a case A, it will be like I resultant is equal to 2i plus, this is 8i plus 2 into 2i into under root basically. So under root 2i into under root 8i into cos of phi, that is equal to 0. Right, simplifying it, it gives 10i plus, it will be root 2, and this is 2 root 2, so this is 4 into 8i, and we are getting I resultant is equal to 18i, and similarly solving for like pi by 2, this complete will be 0, then we will get this. So B case it will be like I resultant is equal to 10i. In case of C it will be minus 1, so it's minus 2. Then C will be the case where I resultant is equal to simply 2i, because it will be like 10 and this will be like minus 8, 10 minus 8, so it will be 2i. That's problem number 4, that matches with option 1. So here, and you can check the option actually. So like next question number 5. Intensity produced by two coherent sources of intensity I1 and I2 constructively will be, so here remember that it's saying intensities are I1 and I2 and constructively. So constructively that directly means phi is equal to 0. Then we know already it's I1 plus I2 plus under root 2 under root I1 into under root I2, and that's all your answer for question number 5. 6. The ratio of amplitude of two wave is 4:3. Then ratio of maximum and minimum intensity. It's simply formula based question actually, question number 6. So I max divided by I minimum. This comes in terms of, this is a A1 plus A2 by A1 minus A2 whole square. This is a simple application from like a formula. So solving it here, it's given A1 and A2 are in ratio, so we can divide it, or I can write it simply. This will be like 7 divided by 4 minus 1, it will be basically 1. So this comes square, that is equal to 49:1 will be the answer for this. And that is next question number 7. When two coherent wave interfere, the maximum minimum intensities are in the ratio of. So question number 7, it's given I max divided by I minimum is equal to, this is 25/16, and we know already it's A1 plus A2 divided by A1 minus A2 whole square. So simply simplifying it, we will get actually here A1 by A2, this comes actually 5/4. Sorry, just wait. So it's let me check the options. The maximum minimum intensities are in the ratio, this we understood. So A1 plus A2, that will be the maximum amplitude actually of resultant interfering wave. These are amplitude of individual wave, remember that. So maximum and minimum amplitude, then yes, it will be like A max divided by A minimum will be simply, here this is the max, this is the minimum, so under root of this, that will be 5/4. And amplitude of individual waves, so simply A max is A1 plus A2 and A1 minus A2 is A minimum. Simplifying it, we get actually A1 by A2 is equal to, it comes 9/1. And then intensity of individual wave will be like proportional to amplitude square, so it will be 81/1. And so this is the ratio of amplitude, ratio of I max or I1 by I2 individual intensity, it will be proportional to amplitude square, so it will be 81/1. So here your option like 1, maximum and minimum amplitude 5:4, amplitude of individual wave 9:1, yes. Intensity of individual wave 41/9, no. Its intensity of individual wave are in 81/1, yes, that's correct. So it matches with actually A, B, D are correct option, A, B and D. I mean like, so it matches with 2. You check the like your options according to this results. Maybe option in different things will be questions maybe in different order. So just take care of the like option, check the answer actually exactly. So let me just erase it first. Okay, next question number 8. The fringe width beta of fringe produced in Young's double slit experiment conducted for monochromatic light of wavelength lambda with the slit difference D and separation between the slit and the screen is capital D. So it's basically formula based here. Beta is the fringe width, and for YDSE setup it's given by lambda capital D by D, where lambda is the wavelength used for light, D is the separation or distance between screen and the slits, and small d is the separation between the slits. So it's straightforward formula based question. That will be your answer. Question number 9. In YDSE, intensity of maxima is I. If the width of slit is double, the intensity of maxima will be, yes. So here what is like happening? So these, we have two slits. This is slit 1, slit 2. Let's say intensity is I naught, its intensity is I naught, then intensity of maxima we get, it's basically 4 I naught into cos square phi by 2. Basically general expression is this, if this is the condition, and we get I max is equal to 4 into I naught. Now what is happening here, and this I max is given as actually I, 4 I naught value is given as equal to I. Now it's talking about is that if width of each slit is double, the intensity of maxima, width of each slit means this width is double. So in this width, if like whatever the width it is been, let's say, double in this manner. So they are made more wide, is it? So here this width is doubled. In this situation, what happened actually, if more light is allowed, then intensity, this I naught prime is directly proportional to this width or slit width. So if this is double, means I naught prime will be 2I naught, is it? and I max will be what? I naught is double, so I max will be like 8 I naught, basically 4 into 2 I naught, and that will be equal to 2 times of initial intensity, and your answer will be like basically 2I. So that matches with fourth option. Question number 10. In YDIC, the slit width are in the ratio of 1:9. Remember that slit width are in the ratio of 1:9. Intensity of maxima to that of the minima. So what it mean actually, like that means I1 by I2 for slit 1, slit 2. This is 9:1 or 1:9? 1:9. Is it? So this is the I1, this is I2. Then it's talking about I max divided by I minimum, and we know it's actually under root I1 plus I2 divided by under root I1 minus I2 whole square. This is the ratio. It's also straightforward formula based problem. Substituting it, so we can take one like it's a 1 plus 3, then it will be 4, and 1 minus 3, it will be 2, so it will be like 4 by 2, it's basically 2, so its ratio will be like 4 by 1, that is 4:1 should be the answer. So that is question number 10 I was talking about. 4:1, yes, that matches with option third. Question number 11. In YDIC, in Young's double slit experiment, the constant phase difference between two sources, so the phi or delta phi, I will write it's pi by 2 is there, and the intensity at a point equidistant from the slit in terms of maximum intensity is I naught. In terms of maximum intensity, it's I naught is okay. In Young's double slit experiment, constant phase difference between two sources is pi by 4. The intensity at a point equal distance from the slit in terms of maximum intensity. Alright, so here maximum intensity is given as I max is equal to like I naught, is it? And that is equal to some 4 into I into sine of cos square phi by 2. Phi is the phase difference. So this complete value is given as I naught basically, or you can write maximum will be like 4I is equal to I naught. Now it's saying at a point where the phase difference is equal to pi by 2, then what will be the intensity? So I prime, I will write it's basically this quantity will be I naught, so it's I naught into cos square into phi is equal to what? Pi by 2 divided by 2, and that comes out to be I naught by 2. That's your answer for question number 11. Question number 12. The path difference between two interfering wave at a distance of pi screen is okay. Question number 12. So here delta x is given as lambda by 6. Then you must know the relation delta phi is equal to what? 2 pi by lambda multiplied by delta x. Simply substituting 2 pi by lambda multiplied by lambda by 6, we get it pi by 3. This is the phase difference, delta phi. Next it's asking from the path difference between two interfering wave at a point on the screen is lambda by 6 from central maxima. The ratio of intensity at this point and that at the central fringe will be. So I central, I will write it's basically 4 I naught. If I naught is the intensity of each individual slit, and then intensity of maxima, central maxima is 4 I naught. In general terms, we write I is equal to 4 I naught cos square phi by 2. Right? So here at central maxima, phi will become 0, so then it becomes simply 4 I naught. Now it's talking about the ratio of intensity at this point where phase difference is this or path difference is this compared to central maxima. So we got central maxima intensity. Let's calculate intensity at this point, is it? So intensity corresponding to this, so I will be equal to 4 I naught into cos square phi is equal to pi by 3 divided by 2. Then ratio of this divided by this divided by I central, that will be 4 I naught, this cancelled, and it's coming out to be simply cos square pi by 6, and cos pi by 6 basically root 3 by 2 whole square, that's 3 by 4, that's coming out to be 0.75. I hope you understood this. Simply it's saying at a point the path difference is this implies phase difference is equal to pi by 3, right? Phase difference. And now it's saying if I am considering, let's say the intensity at central maxima is 4 I naught, then intensity at a point where phase difference is this is given by this expression. 4 I naught cos square, 5 I2. Phi is pi by 3, just substituting it. This divided by the intensity of central maxima is the ratio, and so simplifying it, we are getting it 0.75. Okay, so this is up to question number 12. Next question number 13. So it's saying the phase width at a distance of 50 cm from the slit in Young's experiment for the light of wavelength. So lambda is given as 6000 angstrom and capital D is given as 50 centimeter. Their beta is given as 0.048 centimeter. Alright, light of wavelength. Okay, this the phase width at the same distance for lambda is equal to, so it's asking beta prime will be what when we are changing it lambda prime to 5000 angstrom, and whatever small d is there, let's keep it constant. So we know actually beta is equal to what? Lambda capital D by small d, and it's equal to 0.048, and that is equal to lambda 6000 multiplied by capital D by small d. Next, it's let's say beta prime, and when it's 5000 capital D by small d, because many things are kept constant, so simplifying it, this is all gone, dividing it, and we are getting basically this is also gone. So beta prime is equal to 0.048 divided by this multiplied by 5 divided by 6, and simplifying it, beta prime actually it's like 6 8 and 0.04 whatever is centimeter will be your beta prime phase width. So question number is like concept 1. Question number 14. Phase width in Young's double slit experiment on a screen is produced at a distance of 1 meter from slit. So capital D is given as 1 meter, small d slit width is given as 10 to the power minus 3 meter, and the wavelength light is 6 into 10 to the power minus 7 meter. Now it's talking about phase width. So beta is equal to lambda capital D by small d. Simple straightforward formula based problems. Lambda is coming out to 6 into 10 to the power minus 7 multiplied by capital D divided by 10 to the power minus 3. So it's coming out to be beta is equal to 6 into 10 to the power minus 4. This is your answer, and given in meter. Question number 15. First, diffraction minima due to single slit diffraction is at theta. So now it's about diffraction, and theta first minima will be at theta is equal to 30 degree. For a light of wavelength, lambda is equal to 5000 angstrom, and what else is given here? So width of the slit. So means it's B, it's asking. So we do actually sin theta for first minima is coming out to lambda by B, and this is given as sin 30 is equal to lambda is 5000 10 to the power minus 10 divided by B. Solving it, we are getting B is equal to like half, so it's basically 2 multiplied by 5000 into 10 to the power minus 10, and this will be like 10 to the power 4, and it's 8 10 to the power. Simplifying B is equal to 10 to the power minus 6 meter, and that's equal to what options are given actually. It's also equal to 1 into 10 to the power minus 4 centimeter. Answer. Question number 16. The plane microwave are incident on long slit having a width of, so small b is 5 centimeter. The wavelength of the microwave with the first minima is found at, so here theta for first minima is given as 30 degree, lambda it's asking, and B is given to you. So it's basically straightforward this formula this problem. Here lambda it's asking, so lambda is equal to what? B sine of theta 30 degree, that is equal to B is 5 multiplied by sine 30 is 1 by 2, sine 30 degree, and it's 2.5 centimeter will be the answer for question number 16. 17. Radiation of wavelength lambda is equal to 2 into 10 to the power minus 3 meter fall on a slit width is 4 into 10 to the power minus 3 meter. The angular dispersion for the central maxima will be, okay, so this is talking about, because now listen it, radiation of wavelength this fall on a slit, so means it's a single slit, and that there it's only diffraction possible. So diffraction is talking about, because it's not mentioned to you that it's talking about like it's talking about width, angular width of central maxima, but not whether interference or diffraction. So it's given a slit means it's talking about single slit. So now we know the angular, and another point it's talking angular dispersion of central maxima. So in which, at what angle the central maxima is spreaded, actually it's talking about. Here we calculate theta, it's the angular position of basically like first minima, or up to which from center to what angle your central maxima is spreaded. But it's talking about total angle from top like first minima to bottom first minima. So let me first calculate simply theta plus 1 into, so I will take sine theta is equal to what? Lambda by b, and that is equal to lambda is 2 into 10 to the power minus 3 divided by 2 into 10 to the power minus 3. So sine theta is equal to 1 by 2, which implies theta is equal to 30 degree. Then width of dispersion, I will write dispersion of central maxima, that will be 2 times of theta, and that's equal to 60. So up to problem number 17. Next question number 18. They are saying what will be the angle of diffraction for first secondary maxima. Remember that first secondary maxima, basically secondary maxima is talking about. So if this is the, then here we get basically like this. So this is the first minima, and it's like saying first, and this is the central maxima. Like first secondary maxima is this basically. So it's talking about angle or theta corresponding to this first secondary maxima. Next question number 18. What will be the angle of diffraction for first secondary maxima due to diffraction at a single slit of beam? So small. Here beam is given as 0.5 mm, and using light of lambda is given as 550 nanometer. Then we must be knowing sine theta for first secondary maxima is given by 3 lambda by 2 times of d. Simply substituting, it's talking about this theta. So that would be like 3 into 550 into 10 to the power minus 9 divided by 2 multiplied by d is 0.5 into 10 to the power minus 3. Is it? And simplifying it, basically, it's talking radian and outward we have taken, yes. So, alright, so it's 10 to the power, this is simply 1 10 to the power minus 6, and it will be like 0. This will be like multiplying it 0 and 61 into 10 to the power minus 6, and that can be written as 0. It's like 0.00165, but option is not there. It matches the nearest one is 0.0015, and that would be your answer actually. For sine theta, small value is equal to this, sine theta is equal to theta. So radian, this will be your answer for question number 18. 19. The ratio of magnetic dipole moment to angular momentum in a hydrogen-like atom. So it's a standard basically m divided by l is equal to q divided by 2m, and that is equal to e by 2m will be the answer. Second one, question number 20. The ratio of hydrogen atom, radius of hydrogen atom when it is in second excited state. So second excited state, see, it's simple like nucleus, ground state, first excited state, n equal to 1, n equal to 2. Second excited state, n is equal to 3. Right? Now it's talking the radius of hydrogen atom where it is in the second excited. So r is equal to a0 into n square by z. Z is equal to 1. So here in ground state, it's basically r0 is equal to a0, and r in second excited state is equal to a0 into n is equal to 3, so it's 9. So radius will become 9 times. So that will be your fourth option. Question number 21. The order of size of nucleus and Bohr radius of an atom respectively. This is like a standard question, memory based. You must be knowing the order of the nucleus is of the order of 10 to the power 14 to 10 to the power basically minus 15, but it's mentioned here 14. And the size of the atom is of the order of 10 to the power minus 10 meters. So here on it matches with option 1. Question number 20. This is actually question number 22. I missed question number 21. 21 is saying for electron in nth orbit of atom, the angular velocity is proportional. So we know V is equal to R omega. This implies omega is equal to what? It's V by R. Now you must know the relation of V and R in terms of n. Then only you can answer it. So that's why it's important for you people to remember the relations that we derived in for velocity and radius. So if you substitute the value V is equal to actually E squared by 2 epsilon naught h into this is z by n, and R is equal to m e epsilon naught h square by pi m e square into n square by z. Right. So it's talking about angular velocity, and it's just talking about the proportionality. You can just forget about this part. So it will be like V by R. So it will be 1 by n multiplied by this will be like n square z. You can just simply forget. So it comes out to 1 by n cube. This is like omega is directly proportional to 1 by n cube. And that's matches with option number 4 for question number 21. 22 is this. Question number 23. In the lowest energy level of hydrogen atom, electron has angular momentum. So we know actually angular momentum is mvr nh by 2 pi. The lowest energy state means n is equal to 1. So angular momentum is h over 2 pi is the answer in lowest energy state. Question number 24. Atomic hydrogen is excited to the nth energy level, the maximum number of spectral lines which it can emit while returning to the ground state. You must understand once this question what it is saying. So it is saying like if let's say this is the ground state. If hydrogen atom is excited to first excited state means this is n equal to 1, n equal to 2. Principal quantum numbers. So if it is excited to first excited state, then there are only the possibility of 1 lambda, 1 radiation emission. When it is like the electron is coming back to the ground state, 1 radiation can emit. If it is excited to second, then it can emit 1 here and another here. So excited to 2, then it can emit 1. Excited to like n is equal to 3, then it can emit 2 more. Excited to 3, then it can emit basically 3 more. So on. And now it's saying it's excited to n actually. So it will be like adding, it comes up to n. Total number of radiations emitted is equal to this, and adding it comes into n into n minus 1. N minus 1 divided by 2. This is the total number of possible radiation emitted when an hydrogen atom is excited to n orbit or nth energy level. So question number 24. Atomic hydrogen is excited to nth energy level. Nth energy level. Here energy level is 1, 2, and equal to nth energy level. In total, this many number of radiations can be emitted. Adding this to get in general terms, it's n into n minus 1 by 2. That option matches with first. Question number 25. The unit of Planck's quantum constant is equivalent to, so Planck constant is equal to E is equal to h into nu. Nu is the frequency that is equal to terms of unit which comes out to second. So this implies its energy into second. Energy is equal to m L square into T minus 2 into T, and that comes h is equal to m L square into T minus 1. And you just need to check like which has same dimension. So energy definitely not, velocity also not, force it actually matches with angular momentum. So angular momentum is equal to L is equal to I into omega. This also comes m L square into T minus 1. Because omega is T minus 1 and I is m R square, that is m L square. So it matches with x. Okay, question number like option 2. Question number 26. Which of the following parameters are the same for all hydrogen-like atoms and ion in their ground state? So question number 26. radius of the orbit, so we know actually r is directly proportional to n square by z, so it's not, it cannot be same for all hydrogen like atoms because it depends on z. Speed is directly proportional to z by n, so speed of electron, that also not. Energy of atom, like energy E is directly proportional to n square by z square, so this is also not same, or it cannot be same for all hydrogen like atom. Orbital angular momentum of the electron, that is equal to n is equal to nh by 2 pi. So if I am taking n is equal to 1 or 2 or 3, it's not depending on the atomic number, so that's why for all hydrogen like species L can be same. So question number 26, the answer is fourth one, angular momentum. Okay, next question number 27. An electron passes undeflected through perpendicular electric and magnetic field of intensity. So electric field of intensity, question number 27, E is 3.4 into 10 to the power 3 voltmeter, and magnetic field is 2 into 10 to the power minus 3 Weber meter square. An electron is passing undeflected electron, which is possible only when F electric become F magnetic equal and they cancel each other, then net force on the electron will be 0, and F electric is Q into E, I will write E, and this is E V bar cross B bar, so this implies V is coming out to be E by B, and that is 3.4 into 10 to the power 3 divided by 2 into 10 to the power minus 3, that comes out to 1.7 into 10 to the power 6 meter per second. That's the answer. Question matches with option 1. Question number 28. In Millikan oil drop experiment, a charged drop of mass 1.8 into 10 to the power minus 14 kg is stationary between plates. The distance between plates is 0.9 centimeter and potential difference is, so question number V is given 2000 volt, D is 0.9 centimeter. This implies electric field between the plates is V by D, and mass of the oil drop is given as it's 1.8 into 10 to the power minus 14 kg. So, and the number of electron, the Millikan oil drop experiment charge drop stationary. So charge drop is stationary when QE is equal to mg. We just need to balance that. So mg is equal to 1.8 into 10 to the power minus 14 multiplied by g, I can take it almost 10, and q is equal to n into charge of one electron, because it's asking number of electrons has been removed from the drop, so it's basically 1.6 into 10 to the power minus 19. If one electron is removed, then n will be 1. So q, this is multiplied by e is given as directly v by d, so it's 2000 divided by 0.9, and it's 0.9 is in centimeters, so 10 to the power minus 2. It's simple, straightforward. Simplifying for n, we get actually n is equal to roughly n is equal to 5. So 5 electrons have been removed. Question number 29. Alpha particles are projected toward the nuclei of different metal with the same kinetic energy. So remember it. This is the nuclei of this is nuclei, and Ze is the charge. And alpha particle is projected with some same kinetic energy, so means half mv square is the kinetic energy. And what will be the distance of closest approach, where this complete kinetic energy will be converted into potential energy, so that we can write it's like k, or I will write 1 by 4 pi epsilon naught into minimum r approach is r square multiplied by charge on alpha, so q alpha multiplied by Ze. Is it? So this is constant, so r square is directly proportional to basically under root Ze. So I will write r is proportional to Z. Is it? So whichever is having minimum Z will be equal to, like, where the separation or the distance of closest approach will be minimum. So it's talking about a alpha particle projected towards the nuclei of the different metals with the same kinetic energy. The distance of closest approach is minimum for Z. So we need to just check the value, minimum value of Z, and that is minimum for copper. So it's basically copper, and that is equal to Z is equal to 29. For this, distance of closest approach will be minimum. Question number 30. In the Bohr model of hydrogen atom, the centripetal force is furnished by the Coulombic attraction between the proton and the electron. If A0 is the radius of the ground state orbit, m is the mass, e is the charge on the electron, and epsilon naught is the vacuum permittivity, the speed of the electron. So it's simply mentioning that electron revolving around the nucleus, then proton, is it? The radius for the ground state is given as A0. So we can write the centripetal force mv square divided by r, that is A0. This should be equal to 1 by 4 pi epsilon naught into E q1 q2 by 4 pi epsilon naught into a r square, that is A0 square. So now we are asked to find the value of V. So V is coming out to be E square into A0 divided by 4 pi epsilon naught m into A0 V square, so it will be under root. So V is equal to E by under root 4 pi epsilon naught m A0. This is A0. That matches with option number third. Question number 31. The value of wavelength radiation emitted due to transition of electron from n is equal to 4 to n is equal to 2 state in hydrogen atom will be. Now here you must know the relation of energy or wavelength emitted. So you can derive it. E is equal to RCH into Z square by N square. Either you can derive it from here. So then you can write actually, or you must be remembering it's R 1 by N1 square minus 1 by N2 square. Is it? So difference in energy will be limited in the form of radiation, and that you can write Hc by lambda. Rearranging it, RHc gets cancelled, 1 by lambda comes out to be this. So N1 it's 2 and 2 is equal to 4. So then 1 by lambda is coming out to be R into 1 by 4 minus 1 by 16. That comes out to be simplified 3R by 16. So this implies lambda is equal to 16 divided by 3R. This is your answer for question number 31. Next, 32. If the potential difference applied across Coolidge tube. Now here you must be remembering the Coolidge tube. It's talking about X-rays, because in production of X-ray we use Coolidge tube. So potential difference applied across Coolidge tube means it's basically talking about accelerating potential. So on what things will change if we are changing the accelerating potential. The wavelength of K alpha line, I hope you must be agreeing, it will not change, because K alpha is the characteristic property of the target material, so it cannot be changed. So wavelength of K beta, definitely not. The difference in wavelength between K alpha and K beta will be decreasing, that is also not. None of these, so that's correct option. Fourth, none of these. Question number 33. When a high speed electron beam hits a metal target, okay, when a high speed electron beam hits a metal target, which of the following must happen? So high speed electron beam is hitting a target, heat is produced, yes, some amount of energy of high speed electron will be lost in the form of heat. Continuous X-rays are produced, that is also possible. Characteristic X-rays, no, it's not. High speed electron beam hits a metal target, which of the following must happen? Because must happen, it will depends. Characteristic X-ray will depend actually on the material or metal target. So it may not be, because every metal target cannot emit basically X-rays. Okay, that you must be remembering. Only high atomic number or high atomic metals can emit X-rays, because you must know the process how X-rays are emitted actually. Electrons are either removed out, characteristic X-rays, then they jump, and the energy of that difference in energy must be higher actually, and that is possible only when it's having high atomic number, so means heavy metals. So only 1 and 2 will be the must. If it is simply asking can be possible, then 1, 2, 3 will be the answer actually. It's saying must be, then it's only 1 and 2 cases. Plutonium decay with half-life of, question number 34. Question number 34. So half-life is given, T half is given as 24,000 years, and now it's talking about if plutonium is stored for 72,000 years, then fraction of the plutonium that remains. So 72,000 years means it's 3 half-life, and we know the number of nuclei remain after 1 half-life is given by n naught into 1 by like 2. This is after 1 half-life, after n half-life this. So the fraction after 3 half-life is equal to 1 by 2 power 3, and that will be equal to 1 by 8. Next question number 35. Mass equivalent energy of 931, it's basically 1 AMU mass is converted into energy, then it basically releases 931 MeV, mega electron volt, and 1 AMU is equal to 1.66 into 10 to the power minus 27 kg. You must be remembering, it's theoretical memory based question actually, so you must know the value, then only you can, or either you can convert basically mc square is equal to that, then you will get answer. Which of the following is related with characteristic emission of X-ray? Okay, alpha emission, no, not at all. Like it's question number 36. Because characteristic X-rays, how they are emitted, you must be knowing. In characteristic X-rays, heavy like metal, so what happened from here, one electron is like thrown out, one vacancy is created, then electron from other place is jumping to this. So is it somehow related to alpha emission? Definitely it's not. Electron emission, in electron emission, okay, and positron emission, which of the following is related with the characteristic emission of X-ray? All right, K electron capturing, like alpha electron emission can be also there, but it's also like because every electron emission is also not related to characteristic X-ray. So here positron emission also not. K electron capturing, so K electron capturing, if it is like captured here, then there is creating one vacancy, it's related to basically characteristic X-ray or K alpha line. So it's like most appropriate here, answer is fourth one. Alright, question number 37. Let me first erase this board. Next, question number 37. So MP is the mass of the proton, MP mass of the proton, proton mass, Mn mass of neutron, and a given nucleus of binding energy. So binding energy is given as B, contain Z proton Z, and neutrons number is N. The mass of the nucleus is M, and Z is the mass of nucleus. Okay, C is the speed of light. Okay, so here you must be knowing. So binding energy, we know actually how it actually like. So binding energy B is equal to what? Mass defect. Mass defect is equal to Z times mass of proton plus N times mass of neutron minus mass of nucleus, right? This whole multiplied by C square is equal to the binding energy, basic expression by formula. Then just rearrange it and let's calculate. So M and Z is equal to, this is I can divide, so B by C square, bringing this side, sending it that side. So Z MP plus N Mn minus B by C square. That's the answer for question number 37. Next, 38. On increasing the filament current in X-ray. So filament current means like what it happened, that you must remember from Coolidge tube, what exactly filament current increasing means in the Coolidge tube. So filament current increases result in emission of more number of electron from the thermosensitive filament basically. Because filament current means it's like heating more. Heating more means more number of electrons are emitted, and that result in increasing in the intensity of X-ray. So wavelength of X-ray increases, definitely not. Penetrating power of X-ray increases, no. Intensity of X-ray decreases, no. Intensity of X-ray increases, yes. So fourth, intensity of X-ray increases, that's correct option. Question number 39. Which of the following is not affected by electromagnetic fields? So then you must know the property of alpha, beta, cathode rays and X-ray, and here it exactly matches with X-ray because X-rays are not deflected by alpha, like electric or magnetic field. Alpha particle, it has charge, it deflected. Beta particle also has charge. Cathode rays are also negatively charged, so all shows deflection when electromagnetic field is switched on. X-rays does not show any deflection. So minimum wavelength of X-ray is 2 angstrom. Then the potential difference between anode and cathode, so it's sort of like talking about stopping potential. So we know actually the energy is equal to 12,400 divided by lambda in angstrom in electron volt. So energy of that wavelength, like photon, can be equal to 12,400 divided by 2 angstrom, that is equal to 6,200 electron volt, is it? And if we want to stop it, then we need to apply E into V is this is the volt. E is the charge multiplied by V. So E gets cancelled, so then we are getting 6,200, or that comes 6.2 into 6.2 kilovolt. So this is the potential difference we need to apply across cathode and anode. Question number 40. Okay, next question number 41. X-ray in an electromagnetic radiation. So X-ray photon carry. X-ray is simply talking about the property. An electric charge, it doesn't carry at all. Magnetic movement also not. Both electric charge and magnetic movement, no. Neither electric charge nor magnetic movement. That's correct option D. Question number 42, or basically D or fourth, whatever it is mentioned in your. X-rays are not obtained in the spectrum of hydrogen atom, because again you like it also comes from the basic understanding of X-rays, how it is produced. So X-ray, when like energy is it emitted when the transition, like one vacancy is created and electron is jumping from higher energy state to lower energy state, then the energy emitted of that radiation is very high, then only it will be lying in the X-ray. Because in the EM wave we can see the X-rays comes like at like very far, means like high frequency or high energy. So if there is an atom where vacancy, let's suppose, created, but the energy difference when the electron is jumping is very less, then it will emit radiation, but that will not be an X-ray. Understanding? Because the energy of the frequency of that radiation will not be lying in that X-ray frequency band. So that's why. So here X-ray is not obtained in the spectrum of hydrogen atom. Hydrogen is a gas, no. Hydrogen is very light, no. Energy difference in energy level of hydrogen is very much. That is the best option actually. So 42, it's third option, match is correct. 43, 5 element A, B, C, D, E, A, B, C, D, E, and their work function is given 1.2 electron volt, it's 2.4 electron volt, it's 3.6 electron volt, and D it's given as 4.8 electron volt, and E it's given as 6 electron volt respectively. If light of wavelength, so light of lambda 4000 angstrom is allowed to fall on these elements, then photoelectrons are emitted. So we just need to check for which, like what is the energy of this photon. If energy of this photon is greater than the work function, it will be able to emit the photoelectrons. So let's calculate its energy. That's 12,400 divided by lambda in angstrom. This formula you must be remembering. Substituting 12,400 divided by 4,000, and this comes 0 cancel 4, it's 3, so it's 3.1 electron volt. Now this is the energy of photon, so the threshold or work function must be lower. Let's check for which. A it's lower, B it's lower, C no, none of these. So A, only in case of A and B it will be able to emit photoelectrons. So A and B photoelectrons will be emitted. Question number 43, next 44. If wavelength of lambda 1 is allowed to fall on metal, then kinetic energy of the photoelectron emitted is E1. If wavelength of lambda light changes to lambda 2, then kinetic energy of the electron emitted is E2, then work function of the metal. So here lambda 1, the corresponding kinetic energy is E1, lambda 2 corresponding kinetic energy is E2. Let's say the work function is phi, then what I will write, hc by lambda 1 minus phi is equal to E1. This implies next is hc by lambda 2 minus phi is equal to E2. Now here we just need to simplify these two. So from here let me we need actually phi, so let's substitute the value of hc because in option hc is not mentioned. So here it can be like hc is equal to E1 plus phi multiplied by lambda 1. Substituting it here, E1 plus phi into lambda 2 divided by lambda 1 minus phi is equal to E2, and this is E1 into lambda 2 by lambda 1, and plus phi can be taken out, it's lambda 2 minus lambda 1 divided by lambda 1 equal to E2, just bringing that side, that side, so it's E1 lambda 2, and this is minus E2 lambda 1 divided by lambda 1 is equal to phi into lambda 1 minus lambda 2 divided by lambda 1. This gets cancelled, phi is coming out to be E1 lambda 2 minus E2 lambda 1 divided by lambda 1 minus lambda 2. We just need to check the option of, so here I did some mistake. E1 it will be like I just see here it's E1 lambda 1, so I just made mistake, lambda 1, and this will be lambda 2, so it will be lambda 1 lambda 2, and here also it will be lambda 2, and this is lambda 1 minus 2, and so on. So it's 2, it's 2, and it's 1, and it's 2, and then lambda 1 this 2, and simplifying it, so here E1, and it will be also just inverse lambda 2 minus lambda 1, so it will be like 2 minus 1, just did a small calculation error. So calculating it, we are getting this, and which matches with option third. So this is question number 44. Next question number 45. So here it's saying that if maximum velocity with which an electron can be emitted from photocell is, so 45, Vmax is given as, that is 4 into 10 to the power 8 centimeter per second, and the stopping potential is, so stopping potential, stopping potential, it's basically asking about stopping potential. Okay, so maximum velocity with which electron can be emitted from the photocell, so this is the velocity, and mass of the electron is also given. Mass of electron is 9 into 10 to the power 31 kg. Then I can write what, half mv square is equal to E into V stopping potential. So substituting the value, half 9 into 10 to the power minus 31 into V square, V is the given as 4 into 10 to the power 8, or if I convert it into meter per second, that will be like 6 whole square, and this is equal to E into, E is how much, charge, 1.6 into 10 to the power minus 19 multiplied by stopping potential. Simplifying it, we get actually like it's 9 into 10 to the power minus 31 into 16 into 10 to the power 12 divided by 2 into 1.6 into 10 to the power minus 19 is equal to V stopping potential. This 19, and simplifying it, it comes out to be 45 volts. This is the stopping potential. So this is all about complete paper for NEET DTGs 06. I hope you got cleared your doubt. Thank you so much. Let's see you in the next class with new things.